Welcome to our channel. Today we're diving into the fascinating world of astrobiology and space exploration to uncover the top 9 potential habitable planets for human life. You know, when we contemplate the vastness of the universe with its billions of galaxies and trillions of stars, it's natural to wonder if we're alone. The search for habitable planets is really the search for ourselves, for life as we know it, and perhaps life as we don't yet know it. Let's explore the key factors that make a planet habitable and discover some of the most promising candidates out there. Imagine a campfire on a chilly night. Get too close and you'll be scorched, too far away and you'll freeze. Finding a habitable planet is like finding that sweet spot around the campfire. We call this region the habitable zone or the Goldilocks zone. It's where the temperature is just right for liquid water to exist. Liquid water is essential for all known life forms. Earth in the habitable zone teems with life. Venus is a scorching inferno, while Mars is a frigid desert. The placement of a planet within its star system's habitable zone is crucial. So, when we search for exoplanets, we look at their location relative to their host star. Is it in the habitable zone? This is a fundamental question in the search for life beyond Earth. Now, let's talk about atmosphere. Here on Earth, we take it for granted, we breathe it, we complain about the weather it brings, but we rarely stop to think about how crucial it is for life. An atmosphere isn't just about having air to breathe, it's about having the right kind of air, the right pressure, and the right protection. A thick enough atmosphere can trap heat from a star, keeping the surface temperature stable and pleasant. Without it, a planet would experience wild temperature swings between day and night, making it very difficult for life to evolve. An atmosphere is also our first line of defense against harmful radiation from space. Earth's atmosphere is primarily nitrogen and oxygen, a perfect blend for us and all the other life forms that call this planet home. But other planets might have atmospheres made up of different gases. That doesn't necessarily mean they're uninhabitable. With advanced technology, we might be able to modify these atmospheres, making them suitable for human life. So, when we're looking for potentially habitable planets, we need to consider the atmosphere. Is it thick enough to provide pressure and protection? What's it made of? Could we breathe it, or could we modify it to suit our needs? We all know the phrase water is life. It's a simple statement, but profoundly true. Every living thing we know of, from the smallest microbe to the largest whale, depends on water. It's the lifeblood of our planet, and it's a non-negotiable requirement for any planet hoping to host life as we know it. When we talk about water in the context of habitable planets, we're not just talking about a few puddles here and there. We're talking about vast, stable bodies of liquid water. Oceans, lakes, rivers, the kind of environments where life can truly thrive. Think about Earth's oceans. They cover over 70% of our planet's surface and are teeming with a breathtaking diversity of life. These oceans play a crucial role in regulating our climate, absorbing and distributing heat around the globe. The presence of liquid water on a planet's surface is a strong indicator of its potential habitability. It suggests that the planet's temperature is within a life-supporting range and that there's a hydrological cycle, evaporation, condensation, precipitation similar to Earth's. Finding evidence of liquid water on distant exoplanets is no easy feat. Astronomers rely on sophisticated techniques like spectroscopy, which analyzes the light from a planet's atmosphere to determine its composition. If water vapor is present in significant amounts, it's a good sign that liquid water might also exist on the surface. Chapter 4. Stable climate. Let's be real. Nobody likes a roller coaster when it comes to weather. Imagine a planet where the temperature swings wildly from one extreme to another, where seasons are so intense they could boil your backyard swimming pool one month and turn it into an ice rink the next. Not exactly ideal for life, right? That's why a stable climate is crucial for a habitable planet. We humans are fortunate to live on a planet with a relatively stable climate. Sure, we have our share of storms and heat waves, but for the most part, Earth's temperature remains within a range that allows life to thrive. This stability is due in part to Earth's axial tilt and its nearly circular orbit around the Sun. The axial tilt is what gives us our seasons, but it's a gentle tilt, about 23.5 degrees. If Earth were tilted at a more extreme angle, our seasons would be far more severe. and our nearly circular orbit ensures that we receive a relatively consistent amount of solar energy throughout the year. A stable climate allows for the development of diverse ecosystems and complex life forms. So, when we're searching for potentially habitable planets, we look for signs of stability. A planet's rotation rate, its axial tilt, and the shape of its orbit all provide clues about its climate stability. Chapter 5: Magnetic Field. We often think of a planet's surface as its defining feature, but what about an invisible shield that protects it from the fury of space? That's where a planet's magnetic field comes in. You can't see it, you can't touch it, but trust me, you want your planet to have one. Think of it like a planetary force field, deflecting harmful radiation and particles that are constantly bombarding us from the sun and beyond. Here on Earth, we're lucky enough to have a robust magnetic field generated by the planet's molten iron core. This magnetic field acts like a giant shield, deflecting the solar wind, a stream of charged particles constantly flowing from the sun. Without it, the solar wind would strip away our atmosphere, leaving us exposed to the harsh radiation of space. A planet's magnetic field is a critical factor in its habitability. A strong magnetic field can mean the difference between a planet with a thriving biosphere and one that's barren and lifeless. When we search for exoplanets, the presence of a magnetic field, while difficult to detect directly, is a very good sign. Chapter 6: Surface Conditions. A planet's surface conditions play a crucial role in determining its habitability. It's the surface where we'd be living, building, and exploring. A habitable planet needs a solid surface, or at least significant portions of land. The composition of the surface matters too. We look for surface conditions suitable for life. Chapter 7: Earth. We've spent a lot of time talking about the conditions necessary for a habitable planet, but let's take a moment to appreciate the one we're standing on right now. Earth, this pale blue dot, suspended in the vastness of space, is the only known planet in the universe that harbors life. It's our home, our oasis in the cosmic desert, and it's pretty darn special. Earth ticks all the boxes when it comes to habitability. It sits comfortably in the sun's habitable zone with a surface temperature just right for liquid water. It has a protective atmosphere, a magnetic field that shields us from harmful radiation, and a stable climate that allows for the development of diverse ecosystems. But Earth's habitability goes beyond just checking off a list of requirements. It's the intricate interplay of all these factors that makes it so special. The way our oceans regulate our climate, the way our atmosphere protects us, the way life itself has shaped the very planet we live on. Earth is a dynamic, living planet, and its habitability is a testament to the delicate balance of forces that have shaped it over billions of years. Chapter 8: Mars. When it comes to the search for life beyond Earth, Mars has always captured our imagination. It's our next-door neighbor in the solar system, and while it may appear as a cold desert world today, there's growing evidence that Mars wasn't always this way. In fact, billions of years ago, Mars may have been a much warmer and wetter planet, perhaps even capable of supporting life. One of the most compelling pieces of evidence is the presence of water ice at Mars's poles and in its subsurface. These ice caps grow and shrink with the Martian seasons, and scientists believe they hold clues about Mars' past climate. There's also evidence of ancient riverbeds and lake beds, suggesting that liquid water once flowed freely on the Martian surface. While Mars's atmosphere is thin today, mostly composed of carbon dioxide, it's possible that it was once much thicker, providing a warmer and more hospitable environment. Future missions to Mars will focus on searching for signs of past or present life, as well as investigating the planet's potential for human colonization. Chapter 9: Kepler 452b. Let's journey beyond our solar system to Kepler 452b, Earth's cousin. Discovered in 2015, it orbits within the habitable zone of a Sun-like star. Kepler 452b is about 1.6 times the size of Earth, a super-Earth. It receives similar energy from its star, potentially having liquid water. Future telescopes will study Kepler 452b for signs of life. Thanks for watching. We've journeyed from the fiery heart of our solar system to distant star systems, exploring the fascinating world of habitable planets and the search for life beyond Earth. Remember, the universe is vast, filled with billions upon billions of stars and even more planets. The possibilities for life out there are truly astounding. If you enjoyed this video, don't forget to like, share and subscribe for more fascinating insights into space exploration and astrobiology, and be sure to let us know in the comments which planet you think is the most promising for future human habitation. Until next time, keep looking up, keep asking questions, and never stop exploring the wonders of the cosmos. The universe is waiting to be discovered.